Hi, in this video we are going to learn about normal distributions. To start off, let's review percentiles and z-scores, two ways of describing an individual's location within a distribution. An observation's percentile is the percent of the distribution that is below the value of the observation. An observation z-score is a standardized score that says how many standard deviations the observation lies above or below the mean. These concepts are used heavily along with normal distributions, as will be seen in most AP problems. A normal distribution is a distribution that can be approximated by a normal curve, where the median and mean are at the center of the symmetrical, bell-shaped curve. These normal curves are useful for approximating distributions of repeated measurements, characteristics of populations, and especially chance outcomes. Every normal distribution has a mean and a standard deviation. The mean determines the center, and the standard deviation determines how spread out the distribution is. One helpful property of normal distributions is the 68, 95, 99.7 rule, also known as the empirical rule. By remembering these three numbers, you can think about normal distributions without constantly making detailed calculations. The standard normal table, Table A on your green sheet, is a table of areas under the standard normal curve, which is a normal distribution with a mean of 0 and a standard deviation of 1. Since the total area under the curve is 1, we can use these areas as probabilities. There are two ways to calculate these probabilities. You can either use the table or you can use your calculator. I'll demonstrate how to do both. Here, you can see we have a normal distribution with a mean of 30 and a standard deviation of 5, as well as an observation at 22. We'll call this observation X. Say we want to find the probability of an observation being below 22. Using the table, we would standardize our observation by using z-score equation. We can then find the corresponding area by finding this z-score on the table. Using the calculator, we will run the normal CDF function. This is found by hitting Menu, Statistics, Distributions, and then normal CDF. We first input our limits, in this case negative infinity to 22, our mean of 30, and our standard deviation of 5. Our calculator then spits out the probability, which we can see is a little off from the table but is quite close. On the AP test, either one of these answers is considered correct. Make sure when you do these problems to show all of your work, especially when you use your calculator. Also, after you finish the problem, make sure to add a sentence to put the solution in context.
A normal probability plot is one way that we can determine if a distribution is normal or not. A normal probability plot is made up of raw data, residuals from model fits, and estimated parameters. If the plot looks somewhat linear, like the one that we see here, then we can deem the distribution normal. Another way to determine if a distribution is normal is by checking the conditions of a normal distribution and seeing if the distribution at hand displays these conditions. These conditions include it being symmetrical, it being unimodal, and the mean, median, and mode are all equal. It's right around the center. A few tips to remember for the AP exam would be that if an observation doesn't fall within 1, 2, or 3 standard deviations from the mean, use Table A or some sort of technology on your calculator to identify the proportion of values in any specific interval under a normal curve. It is extremely important that you clearly communicate your methods when answering questions that involve normal distributions. Some common mistakes that people make in these types of problems are when they try to find the percentile of a normal distribution. Sometimes students forget that you are finding everything up until the percentile, not everything past it, like some students do. For more problems on this topic, try looking at problem number 2 on the 2009 AP Stats test.